So again x double dot is equal to v dv dx. Now that problem is easily modeled by the equation. If we look at the problem that is in our minds and heads and notebooks, m x double dot is equal to mg minus k v square. We must remember specifically that m is the mass of the body, although it's not written anywhere in the problem, but that's a foregone conclusion. M is the mass of the body. Now, this we write as m v dv dx. So that x double dot d2x dt is replaced by v dv dx is equal to mg minus k v square. That's it. M, right. Now, mg by k, the entire equation by k, this leads. Dividing by k, what we get is m over k into v dv dx is equal to mg by k minus k by m b square. K by m is 1 over a square. 1 over a square. We'll do that. Let's see. Now, so far there is no error in modeling the problem and in writing the differential equation. We'll check once again. This is m dv dx, mg minus k v square. Next step, we divided by k. So m by k v dv dx is equal to mg divided by k. Yes, we divided by the entire thing by k, so no problem. Minus, oh, we have to divide by k. Here is a mistake. So this becomes minus v square. That's it. And this is nothing but a square minus v square. Distance lends enchantment to the view. I do hope I have not allowed any error to creep in. M, K, V dv dx, it's fine. mg by k is going to be replaced by a square. What did I write? V square is equal to a square by v square. Why? That's not there. So this is actually a square minus v square. Simple. This is mg by k, which is a square, and this v square is a standalone term because we divided by k. So our ultimate equation is m over k v dv dx is equal to a square minus v square. This is what we will put up on the board, rub out portions from here, because these are no longer necessary, although of course I'll keep this for a while. So we just rub out from the top and write the differential equation. M by k v dv dx is equal to a square minus b square. Simple. Now this can go, a square minus b square is gone on top, this is gone on top, so we drop out this part because it will be needed. All this space will be needed when we integrate the differential equation. Here I wish to make a point. Some books, on differential equations use the following language: integrate the following differential equation. Because a differential equation, after two steps, no matter what is the method of solving, just depends on integration. So here we must add that if we are not good in integration, then we will be bad in differential equations as well. But whatever little revision has to be done can be done, especially by students. This has mostly been done in high school, so it will be a revisit. Sorry for that drink of water. We will separate the variables. So we write separating the variables. What we get is v dv over a square minus v square. So v dv over a square minus v square is equal to k dx over m. K dx over m. Now k over m, if we do this, k over m is g by a square is equal to g by a square dx. We've done k over mg as 1 by a square. K over mg is 1 by a square, and we had k by m. Simple calculation. K over a square by m is equal to g by k. So k over g, so k over m, no, what? K over m, k over m. Okay, m over k is a square by g. M over k is a square by g. Simple things take a bit of time. K over m is g by a square. Yeah, k over m is g by a square. So we have, this is equal to g over a square. It's already done. It's fine. Sorry for this mess up. K over m dx is g over a square dx. That's fine. Now we integrate both sides. So put an integration sign. Put an integration sign here. And this is equal to g over a square x plus a constant. And this integral we have to do, what we do is we put a minus 2 here and 1 over minus 2 here, because a square minus v square has a derivative of minus 2v dv. The differential of a square minus v square is this much, minus 2v dv. So in other words, the right hand side is very cool. So here we have minus half log base e a square minus v square is equal to g over a square x plus c, minus half log a square minus v square is g over a square x plus c. That's fine. Now we wish to remind ourselves that when x is 0, v is 0. So that would give us an avenue to find this constant c. I repeat, When V is 0, that means at the beginning, when the body starts to fall from rest, that is also the point where x is 0. So if we keep this and rub out the part on top, we can get a value of C, which we will put back. So here we go. We just take a little bit of time to get the things off the board. Yeah, that's it. That's fine. So we write reckoning, realizing the fact that V is equal to 0 when x is equal to 0. What do? We substitute those values and get minus half log a square minus 0 square is equal to g by a square into 0 plus c. So my friend, c is nothing but, because this term vanishes, this just becomes log a square into minus half. So c has a value of minus half log a square that we capture. C has a value of minus half log a square. This is of course to the base e. So there we are. We can write this equation once again, putting that particular value of c here. So we carry on writing this as gx over a square plus plus this minus is fine, half log a square. So that is it. Minus half log base e a square minus b square is gx over a square into, minus half of log a square. What we can do is we put this x term here and take this term on the right and keep gx over a square on the right. That should not be a problem. So again a bit of rubbing out. My writing is a little large, so I need to rub the board a lot of times. We write gx gives gx over a square is equal to half log a square minus half log a square minus v square. This is nothing but half log a square over a square minus v square. That is gx over a square. So if we write a square as mg by k, mg by k, then kx over m, this implies, gx a square is mg by k over k is equal to half log a square over a square minus v square. Having done that, we can say, cancelling these g's, that kx over m, we can remove this and write this leads to, we say leads to or leading to kx over m G cancels, kx over m is equal to half log a square over a square minus v square. If we just multiply by 2, we get or 2 kx over m is equal to log a square over a square minus b square. There we are. So that is what we had to do. We had to do this. We are home. So we can write we are home. After that last step, we are just home. So that is the end of the problem, but does the solution look logical? Yes or no? You see, excepting at the very beginning, and we will verify the solution, when v is 0, that means at the very beginning, this is log of a square by a square, and that is log of 1, which is 0. So x is 0, and that is of course the condition with which we started. That is of course the condition with which we started, and that is that when v is 0, x is 0. Thereafter, v starts to grow, and the term here is something that is this over something smaller. So what we have inside is more than 1. It is not a fraction, it is more than 1. Had it been a fraction, then it would have been a negative with the log. It would have been a negative quantity. That is not a tenable situation. So this solution is perfectly all right.